So in the last session, we were discussing about a range of trigonometric functions. Up to cosec function we did. Now finally, let's see the range of sec function. So if you just recall, sec is a function from, sec x is a reciprocal of cos x. So sec x is 1 upon cosine x. So here all real numbers minus all values of x, for which cos x becomes 0. So it is 2n plus 1 pi by 2. This much where n belongs to z, 2 r. This just for your information, it. Definition is this. Now, range of cos function is closed interval -1 to 1. That much we know. This is -1, this is 1. So, sec being reciprocal of cos, the range would be other than this portion. So, either it would be in this part or it will be in this part. So, range, we can say that here 1 to infinity, including 1, remember. So, I'll write here 1 to infinity. 1 to infinity, 1 is included, close interval, and -1 to minus infinity. So minus infinity to -1 and combine these two. So union. This is the range. Now alternatively, you can write the same set like this. All real numbers other than this portion. Now this portion means open interval, remember. 1 is included in range. So 1 you are going to exclude from this. So open interval -1 to 1. Range of cosec function, same as sec function. And what's the meaning of this? That is, range is this means for every real number x, this is as I told you earlier, for every real number x, sec x is either greater than or equal to 1, this portion, or you can write sec x is less than or equal to -1, that is either in this portion. That's what the meaning of range of the sec function. This much we know. Okay, so now just recap about the range of the functions. So here if I write the function and here if I write the range, for sine and cos for both the functions, sine and cosine for both the function, range is closed interval -1 to 1. It means, again I'm emphasizing, for every angle x, for every arc length x, values of sine and cos always fall in this interval. Range of tan and cot, for every angle x, values can be any real number. So range of tan and cot function is all real numbers. And cosec and sec functions, for every real number x here, that is the arc length x, range is this r minus open interval -1 to 1. Right? These three things we have emphasized so far. Range of sine and cos close interval -1 to 1. Range of tan and cot is r. Range of sec and cosec is r minus open interval -1 to 1. This is one thing. Now, again I come back to zeros. So, this zeros of a sine function, that sine x, which x equals to n pi, where n belongs to z. Again I just repeat, what's the meaning of this are the zeros of sine function? It means instead of x, if I put n pi here where n belongs to z, then sine becomes 0. What about zeros of cos function, which also we have discussed? Is x equals to all odd multiples of pi by 2 where n belongs to z. right? That is pi by 2, 3 pi by 2, 5 pi by 2, and so on. These are the zeros of sine and cos functions which we did. Now we want the zeros of, we find now zeros of other functions, that is zeros of first 10 function. We find first one 10x zeros, right? We find zeros of this 10 function. What's the meaning of this? We find, as we discussed, we find all x such that 10x equals to 0, right? We get all angle x for which 10x becomes 0. If 10x is 0, that means sin x upon cos x is 0. Tan is sine by cos. You take cos on the other side, so sin x equals to 0. What is the meaning of this? Whenever tan is 0, then sine must be 0, obviously, because sine is numerator. So it means zeros of the sine function is same as the zeros of tan function. Now what are the zeros of sine function? That is n pi, so x equals to n pi. So now you have concluded that the zeros of 10, that is nothing but x equals to n pi, where n belongs to z. This is now the conclusion. I repeat, zeros of 10, it is same as the zeros of sine. What are the zeros of sine? N pi. So zeros of 10 is also n pi. Same way, you can just see that zeros of cot function, cot you know cos by sine, so you can take sine on the other side, so it is just zeros of the cos function, you think. So 2n plus 1 pi by 2. You can just imagine, you can just use the same argument. Zeros of cot, it is as good as zeros of cos function. Okay. Then here next question comes to zeros of which function? Cosec function. Zeros of, let me write both, cosec and sec. Zeros of cosec and sec. Now what we mean by zeros of cosec and sec? We find x such that angle x, all possible angle x, such that cosec x becomes 0 and similarly sec x becomes 0. Now you just need to recall the range of cosec and sec. What's the range of the cosec and sec? It is either this portion or this portion, you know. Values of sec as well as cosec would be more than 1 or less than -1. It will never fall in this interval. Now 0 is here, it means there is no x for which sec x becomes 0. So what's the meaning of this here? Zeros equals to null set. Zeros equals to 5. For which two functions? Cosec and sec. Right? 5 means what? There is no x for which cosec becomes 0, because cosec is always more than 1 or less than -1. You know this. Both the functions, if this is -1 and this is 1, then cosec and sec both are either 1 or more than 1 or -1 or less than -1. So can we get any x for which cosec equals to here? No, never. That means there is no x, so set of zeros is null set. So finally, zeros of the second cosec function is null set. There is no value of there is no value of x for which cosec and sec become 0, therefore the null set is 0. Or you can think other way around also. If cosec is 0, then sine becomes infinity, which is undefined. That's why 0 is equals to null set. Okay. Okay, so now I'll just write what we discussed so far in form of table. So let me rewrite here again function. So first I'll start with cosine. Cosine is a function from real numbers to real numbers. Range is closed interval -1 to 1, and zeros 2n plus 1 pi by 2, where n belongs to z everywhere. These are the zeros. Second function, if I go to second function, which is sine, So sine is again a function from real numbers to real numbers. Range is closed interval -1 to 1. And here, zeros is n pi. Again I'm saying zeros means values of angle for which sine becomes 0 here. Third, I'll go to tan function. Tan function here. Tan is a function from, here real numbers minus 2n plus 1 pi by 2, where n belongs to z, to r, all real numbers. What is the definition of tan x? It is sin x upon cos x. So we have dropped all these 2n plus 1 values here. What's the range here? R. What's the zeros of tan function? That is same as sine function, which is n pi, where n belongs to z here. Where n belongs to z here. The next, I'll come to fourth, cot function. Cot is a function from real numbers minus, cot x is nothing but cos x upon sin x. So you are going to write what here? Minus n pi, where n belongs to z, to all real numbers. Range, all real numbers. And here, zeros of cot function is same as cos function. So it is 2n plus 1. It is 2n plus 1 pi by 2, where n belongs to z. Zeros of cot and cos are same. Zeros of sine and tan are same. Okay. Now fifth function here, that is, let me write cosec function for example. Cosec is a function from r minus n pi belongs to z to r. Cosec x equals to 1 upon sin x. Don't memorize this, just understand why we wrote this minus, because this becomes 0 when x is n pi. Similarly here, just to understand, you will write very easily. Okay. What's the range here? R minus open interval -1 to 1. Every real number other than this set of zeros, null set here. There is no x for which cosec becomes 0. Cosec never be 0. And then next we have sec function. Sec is a function from r minus 2n plus 1 pi by 2, n belongs to z, to r, all real numbers, where sec x is 1 upon cos x, Range same here, r minus open interval -1 to 1, and set of zeros here, set of zeros is 5. Right? So this is very important table, remember here. This is final consolidated table which were discussed so far. About here, zeros of this trigonometric functions. This is about range of the trigonometric functions, and this is about domain and codomain of trigonometric functions. Okay, that's one thing. Secondly, now we have these three identities. You can call them results also, or you can call them formulas also. You know that here basically sine and cosine functions comes from the unit circle, that we know, right? If this is any point P and if this arc length is x, then here first coordinate is cos x and second coordinate is sin x. This we know. If this length is x, then here for any point on the unit circle, the first coordinate is cos and second coordinate is sin. Now if you remember, what is the equation of the unit circle? What was that, if you recall? Equation was this. Equation of unit circle was x square plus y square equals to 1. We had mentioned. Now x and y is any point on the unit circle, but here instead of x on the unit circle you have cos x. So you can write cos x the whole square plus sin x the whole square equals to 1. So this is your standard Trigo identity. Usually the whole square in Trigo is written like this: cos square x plus sin square x equals to 1. This is true for every x, remember, belongs to R. right? This is arc length. For every real number x, this is called angle or arc length. Even you can write theta also, or if you remember, you might have used earlier theta. So you can write cos square theta plus sine square theta equals to 1. What is this theta? For every theta belongs to our real numbers, remember, where theta is called arc length, as we have discussed in the beginning. So cos square theta plus sine square theta is always 1, remember. You know that the values of cos and sine never be beyond 1. So there's one standard identity. Cos square plus sine square equals to 1 for every real number theta. I've used theta, here I've used x. Anything can be used, remember, this is just a variable. So there's one standard identity. Okay. Now next, you have this here as sine square x plus cos square x equals to 1. You have this is equals to 1. Now you know this, remember. You can divide throughout by cos square. If I divide by cos square, so this is sine square x by cos square x. This is plus 1. This is 1 upon cos square. Dividing by cos square. What is sine square by cos square? That is tan square. This is plus 1. What is 1 by cos square? It is sec square. So this is another standard identity which also you know. 1 plus tan square equals to sec square. You can write, if you want, alternatively sec square minus tan square equals to 1. You can write like this also. Sec square x minus tan square x equals to 1. All are same, remember. You can write like this also. Take tan square on the other side. So 1 was this identity. Sine square plus cos square is 1. This is 1. The second important identity is 1 plus tan square is sec square. You know it from 10th standard. And again, you divide equation 1, this identity 1 by sine square now. So this is 1, this is cos square by sine square, and this is 1 upon sine square. Okay, so this is 1 plus cot square x. Cos by sine is cot, you know, and this is cos square. So this is another standard Trigo identity from 10th standard. Proofs are not important how we are getting, but identities are important. Sine square plus cos square is 1. 1 plus tan square is sec square. And 1 plus cot square is cosec square. You can write cosec square minus cot square equals to 1, remember. Okay. That is one thing. So now we have these 3 standard identities. Here one thing must be noted, remember, when you write sine square x, its precise meaning is this, remember, sine x the whole square. But this and this are different, remember. When you write like this means square of angle. Okay, so this is not same as this. This is not same as sine x the whole square. So don't get confused this. When we write like this is just a way of writing. It means it's a whole square. Right? For example, you know, if I write sine square, let me write, for example, you know, from 10th standard 45 degree. Right? Now you know sine 45 degrees 1 by root 2. You know this much. So 1 by root 2 whole square. This means is this, and that is finally 1 by 2. One more, if I write, for example, let me write cos square pi. What's the meaning of this precisely? Cos pi the whole square. Just I'm giving you little bit clarity about this square and this square, both are same. What is cos pi? The easiest way is just imagine unit circle in your mind. Where is pi here? This arc length is pi, you know. Okay. Cos function represent which coordinate? First coordinate. What is the first coordinate here? -1. Second coordinate is 0. That means cos pi is -1. -1 whole square. So 1. So cos square pi is 1 that way. But this is different, remember. If I write cos pi square, this is different. It is not same as this, remember. So be careful about this. Cos pi square, it means you square pi first and then you find the cos value. That way. So this should be clear to you. That's one thing. Okay. Now next theory point is about sign of trigonometric function. Sign of trigonometric functions. Trigonometric functions. Positive or negative, that we want to determine in each quadrant. Okay. So trigonometric functions are mainly depends on this unit circle. So I'll consider unit circle. So you have these 4 quadrants. This is the first quadrant. This we know. This is the second quadrant. This is the third quadrant. And this is the fourth quadrant. This much we know. If you choose any point, then it would have 2 coordinates. Both the coordinates are positive, x and y. If you go to this, here x is negative. So first coordinate negative, but here y, this is x. So second coordinate is positive. Here x is negative, y is negative. So both the coordinates are negative. Here x is positive, but y is negative, opposite of this. This much we know. You already studied such things about these 4 quadrants and about signs of coordinates in these 4 quadrants. You know this much. Now when I imagine unit circle here, then the first coordinate is cos function. So this is positive. So in the first quadrant, cos is positive. Right? If I write here, for example, quadrant 1, here 2, here let me write 3 and 4. Let me start with cos function here. So cos is positive in first quadrant. Okay. What about sine function in the first quadrant, which is also positive? This is positive. Because this represents sine function, sine x. If you imagine unit circle and arc length x, this is cos x. So cos and sine both are positive in first quadrant. If cos and sine are positive, I'll just write tan. Tan is also positive. If tan is positive, cot is reciprocal of tan. So this is also positive. And sine and cos are positive. So sec is positive and cosec is also positive. Where? In the first quadrant. Plus sign means they are positive. It means all these trigonometric functions are positive. So we use the one word all in first quadrant. Okay. Here first coordinate is negative. That means cosine is negative. Second is positive. So sine is positive. This is positive. This is negative. So here in the second quadrant, cos negative, sine positive. If one negative, one positive, tan is the ratio of these two. So this is negative. Tan is negative, cot is also negative because it's just a reciprocal. Sec is reciprocal of cos, so it would be positive. Negative, because cos is negative. So here it is negative. Sec is the reciprocal of sine, so it is positive. So which functions here are positive? Sine and its reciprocal. So we use here S, right? So S stands for sine and its reciprocal. So sine and cosec are positive, remaining all are negative. All S. All means all trigonometric functions are positive in first quadrant. S means sine and its reciprocal. Sine and its reciprocal is cosec. Both are positive, remaining all are negative, remember. We'll use effectively later on, remember. This is a fundamental of trigonometric functions. So I'm taking so much time. Third quadrant, both are negative. So here cos negative, sine negative. If both are negative, the ratio would be positive. The ratio would be positive. Sec obviously negative. Cosec obviously negative because sine is negative. These two are reciprocal of these two functions. So what you notice here? Only tan and cot are positive, remaining all are negative. So we have here T. So T stands for tan and its reciprocal, that is cot, are positive, remaining all are negative. Come to fourth quadrant. Here first cosine. second you know sine. So cos is positive, sine is negative. If one is positive, the other one is negative, the ratio would be negative, right? Ratio of these two is negative. Sec would be positive, cosec will be negative. So here which two functions are positive? Cos and its reciprocal. So we'll use S here. So this is the statement which we use frequently in trigonometric functions throughout 11th and 12th standard, even in physics also. All STC. All means all trigonometric functions are positive in first quadrant. S means sine and cosec are positive, as I mentioned. T means tan and cot are positive, and S means sec and its reciprocal are positive. This means all trigo are positive. All trigo are positive. S means, what's the meaning of S? S means sine and cosec are positive. Remaining all are negative. T means tan and cot, both are positive. Remaining all are negative. S means I'm sorry, why S? C here. This is my mistake, because cos and sec. So here C means cos and its reciprocal sec are positive. So this is a statement which we remember, all STC. All STC. All trigonometric functions are positive in first quadrant. Second quadrant, sine and its reciprocal, that is cosec, are positive. In T means third quadrant, tan and cot are positive, remaining all are negative. C in fourth quadrant, that is cos and sec are positive, remaining all are negative. This way we will determine the sign. For example, if I write here, let me write, for example, right now it's difficult to say, but for example I'll write sine. Let me write, here if I start with this, arc length is 0. Here arc length is 90 degree, relation. Pi by 2 means 90 degrees. Suppose if I move little further, here 100. So suppose I'll write sine 100 degree. Now without scientific calculator you cannot get the value of sine 100 degree. You will realize later on also. But at least you can say that 100 degree is in which quadrant? Second quadrant. Now sine is positive in the second quadrant, so this must be greater than 0. Positive. It has to be positive, whatever it is. You just use scientific calculator. You can verify if you have in your mobile or in your computer. Sine 100 degree has to be positive. If I write cos 100 degree, so immediately you can say that 100 degree is in which quadrant? Second quadrant. Why? Here 0 degree, arc length is 0. Here arc length 90 degree, which is pi by 2. 100 means somewhere here. It is in the second quadrant. In the second quadrant cos is negative, so it has to be less than 0. That way we can answer whether the function is positive or negative in a given quadrant. So the moral of the conclusion of this entire discussion is this statement: all STC, all trigonometric functions are positive. Sine and cosec are positive. Tan and cot are positive. Cosec and sec are positive. Okay, so that's one thing. Next part is here. So next theory portion is increasing decreasing functions. That is, we want to write behavior of trigonometric functions. This would be useful even to draw the graph of the functions. So again I would come to unit circle. Unit circle here. These are the 4 reference points, coordinates A 1 0, A dash minus 1 0. This is B of 0 1 and B dash 0 minus 1. These are the 4 reference points. Unit circle means this is 1 unit, so 1 0. This is again 1 unit, remember. This is 0 1. On the y-axis, x coordinate is 0. Here 0 minus 1 and here minus 1 0. Now We did number of times, and now you know the first coordinate represent the values of which function? Cos function. There is a first quadrant, you know. There is a second quadrant, there is a third quadrant, and there is a fourth quadrant. That much we know. Okay. Now let me write here quadrant wise. So first quadrant here, second quadrant, third, and fourth. These are the four quadrants. Let me first start with the sine function here. First sine function. So sine function means second coordinate. Here the value of the sine function is 0. Now as you move like this, you are increasing, remember, arc length. Here arc length is 0, now arc length become pi by 2. You know, here x is 0. You are increasing arc length, here arc length become pi by 2. From this to this, which is 90 degree, you know. This is as good as 90 degree. Pi is 180 degree, convergent you know very easily now. Here 0, here 1, so 0 to 1. So it's here increases from where to where? 0 to 1. So I'll put upward arrow. Upward arrow says that in this quadrant sine increases. Sine increases means what? Values of the sine increases. That's one thing. Now go to second quadrant. You are concentrating right now for sine function. So in the second quadrant, here second component. Here second component is 1. Here second component is 0. So if you move from pi by 2 to pi, you know arc length here pi, which is 180 degree. You know this. Pi or 180 degree. So from this to this, 90 degree to 180 degree, 1 to 0. So sine is decreasing. Decreasing means values being decreases here, 1 to 0. Go to third quadrant, pi 2, here 3 pi by 2. 3 pi by 2. We are concentrating for sine function, remember. So second coordinate 0, 2, minus 1. So again decreases. So in the third quadrant, values of the sine function decreases. Go to fourth quadrant, 3 pi by 2, 2. Now after one revolution, arc length become 2 pi, which is 360 degree. Right? So here one revolution. Earlier it was 0 or 0 degree you can write. Now second component minus 1 to 0. So you have this increasing function. So what we have noticed here, in which two quadrant sine is increasing? In first and fourth quadrant sine is an increasing function. In the first and fourth quadrant, values of the sine function increases, values go up. Okay, cosine function now, same way. Cos function in the first quadrant, that is the first coordinate, 1 to 0, decreasing. 1 to 0. Second quadrant, 0 to minus 1. 0 to minus 1, decreasing. Third quadrant, here minus 1 to 0. Minus 1 to 0, so it's increases. And 0 to 1, it's increases. So here cos is increasing in which two quadrant? Third and fourth quadrant. Sine is increasing in which two quadrant? First and fourth quadrant. This is in third and fourth quadrant. Now 10 you cannot answer from unit circle. It's a ratio of these two. Now again, without proof I'm writing, it is an increasing function in each quadrant. Without proof I've stated this. As you increase value, sine function always increases, remember. As you increase the angle, here in the first quadrant, if you increase the angle, cos function decreases. But tan function increasing in each quadrant. What about cot? Once the tan increases, cot is reciprocal of tan, so it is a decreasing function. In each quadrant, tan is decreasing. Now cosec and sec you can write very easily from this. What about cosec? It's a reciprocal of sine function. Here it is increasing, so this is decreasing. Decreasing, so it's an increasing. Decreasing, so increasing. Here increasing, so decreasing. There is a behavior of cosec function. This is not so important. First three functions are important. Remember this, you can write from there only. Cosec, decreasing, so this is an increasing. Decreasing, so this is an increasing. These two increasing, so decreasing. right? As I told you, the first three functions are very important here. In first and fourth quadrant, sine is an increasing function. In which two quadrants sine increases? First and fourth. Cosine increases in third and fourth quadrant. Tan increasing in each quadrant. These three are important. Remember, you need to remember as far as theory point of view. The other things you can write. Tan is increasing everywhere. So we, I think, keep this much only. This still theory portion is going on. So you might have, the impression that the when we are going to start the sum will start very soon. First, I'm preparing some foundation for trigonometric functions. Okay, next time we'll see further.